Oh, sorry, I think I might have muted there for a minute. Let's go through what I was saying again there. So what is geology? So it's actually one of the earth sciences. So the earth science is a very wide field. So it encompasses atmospherics, it encompasses the ocean, the cryogenics, so the ice. So it's one of those, one of the earth sciences. Actually study of the earth, okay, rather than just rocks. So it's processes that occur on the earth and in it. So it can range from the global plate tectonics that cover the whole planet to the weathering of tiny pebbles and everything in between there. So all the volcanoes, all of the other rock processes, which we'll talk about in a moment. So you might know about some of the subdisciplines of geology. So these all come under geology. So you've got paleontology, which means the study of ancient life. It's includes dinosaurs, but not just about dinosaurs. It's got you see there's a shell. It's called an ammonite, so it was a bit like a squid in a shell. Quite beautiful shells that they had. Volcanology, study of volcanoes. And predicting their activity, because they're actually quite difficult to predict when they live up. So that's a very important subdiscipline of geology. And petrology. So you might not have heard of that one. Petrology is the study of rocks themselves. Like all of the rock processes is actually petrology, but it's under geology, so you can generally call it geology. But geology is a very wide-reaching term. Okay, so it's best to start at the beginning, isn't it? We'll talk about geology. So where did the Earth come from? So first of all, the sun formed from a nebula. So it's just a big cloud that formed the sun. And after the sun formed, there was a spinning disk of gas and dust around the sun. Okay, so it's known as a protoplanetary disk. So the Earth and the rest of the planets actually formed from this dust. So you may think, Earth is a bit different to the other planets, but different to Jupiter, but different to the other gas giants, and there is a reason for this. So the disk was actually mainly made of hydrogen and helium, a bit like what the sun is made of itself, with other trace elements. So things like iron, nickel, silicon, which we think about probably the Earth being made from, it's actually very small amounts compared to the hydrogen and helium. So they're heavier than hydrogen and helium. If you've ever had a helium balloon in your house, you know that helium is very, very light element. So the iron and the nickel all stayed quite close to the sun. So we sort of highlighted, they stayed quite close to the sun, and they formed the inner planets. So Mercury, Venus, Earth, and Mars formed from the heavier elements that remain closer to the sun. So the lighter elements, like the hydrogen, helium, methane, kind of what we know the gases, they were swept out further in the solar system. So they went into forming the outer planets. So Jupiter, Saturn, Uranus, and Neptune. They went into forming those planets, and also that you might think, well, that they're just gas, but they're not. They're rocky cores. Not as metallic as the Earth is, because again the elements are lighter out there, but they've got a rocky core, and they just formed huge atmospheres. Also, the temperature out there helped to condense some of the gas, so it was actually denser, and actually would sort of adhere to the rocky core a bit better. But they're very different, yes, the inner planets. So the inner planets are Mercury, Venus, Earth, and Mars. Rocky, got metallic iron cores, that iron nickel. The outer planets, rocky cores, but made of gas. Mostly. They've got huge atmospheres. Okay, so focus on the Earth, okay, for geology, because it's geo, the Earth. So when the Earth first formed, it was molten. Okay, so it was a bit like just sort of a huge ball of lava. You can see here it's sort of like it's showing it's starting to solidify, but it's also got molten parts. So it was within this time, it was about 4.6 billion years ago. Within this time, that the planet, probably about the size of Mars, so it could have been Mars, could have been another planet around then, actually collided with the Earth to form the Moon. So some of the Earth came off and started orbiting. So really, Earth had a ring system for a while and actually formed the Moon. Okay, so ring systems on any planet are not permanent. So Saturn's ring system actually will only last a few million years before it coalesces back into a moon again, because it was most likely a moon that's been broken up. So luckily we see it at its most beautiful time, but any planet can have a ring system for a while before it recoalesces to a moon. So that's how we got our moon, was a body colliding with the Earth and creating the moon. Okay, so let's have even more focus on the Earth. Okay, just the Earth itself. So You might be used to seeing, oh, the Earth's got a core, it's got a mantle, and it's got a crust, but we're going into a bit more detail. So right in the centre, you've got the inner core, so it's solid, iron and nickel. So it's solid because it's under a lot of pressure. Okay, also the heavier elements have sunk further into the planet. So they formed like a big homogeneous ball, but then the heavier elements sank to the core, sank to the middle, just because they're heavier. So you ended up with a solid inner core and a liquid under a little bit less pressure, liquid iron and a nickel core, outer core, but it's actually rotates. So it's a liquid iron nickel metallic mix that rotates, and that actually gives us our magnetic field. So when you have a compass, that's actually what it's powered by, really, is the compass is pointing towards the north and the south magnetic fields, which are caused by the rotating outer core. Okay, so that's something that's very interesting there and useful to navigation. You also had the mantle that you split up. Okay, so it's still got the mantle, but it's just split up into the mesosphere, which doesn't really move. Okay, and the asthenosphere. And both of these are semi-solid, so they're not actually they're not molten as in the lava you see at the surface. They're under a little bit more pressure than that. So they actually are semi-solid. They can flow, they can move, especially the asthenosphere moves, but they move very slowly. It's a little bit like sort of if you got sort of caramel warmed up a bit. It's still solid, but it can flow. That's what I always sort of tell students. So on top of the asthenosphere, so just on top of it, sits the plate. So tectonic plates sit on that, and they're part of the lithosphere. Okay, the lithosphere, yeah, is the crust, so what we stand on, you're more familiar with, and the uppermost part of the mantle. Okay, so yeah, the lithosphere. So you got people confused a little bit about that, but lithosphere is the crust and the upper part, because the continents actually have what's called a root, like a tooth. They have like a root that goes down, okay, a little bit into the mantle, so it kind of sinks into the mantle a little bit. Yeah, so they're not just flat on the Earth. They actually have a root system to them. Okay, it's actually called the root of a continent. Okay, so that's where the continents sit on. Okay, so talking about plates, let's go to the next slide. So tectonic plates. So these move very slow. So it's a little bit like if you had a boiled egg, and like a hard-boiled egg, and you cracked it. Like the cracks on the egg, kind of a little shell fragments, sit on the egg still. It's a bit like that. How I explained it to somebody once. They move very slow. They've rearranged themselves over millions of years. They're driven by the mantle moving. They only move a few centimeters a year, but that's significant enough to cause earthquakes and tsunamis and volcanoes. So anything that's sitting on the plate, like Japan here, will experience lots of earthquakes and lots of volcanoes. And Iceland over here, Iceland sits right in the middle of the North American and Eurasian plate, and they will move past each other, and they will actually create earthquakes. So if you see what a plate boundary, earthquakes will occur. Earthquakes can occur within the plate, so that you can get earthquakes in England. You might have heard some in the news before, but it's caused by tiny cracks within these plates compared to these big plate margins. And that's why over time the continents actually sort of shift around, because you can see that the continents sit on these plates and then they move around. It's quite apparent if you printed out a map of the world, that the African plate actually fits into the South American plate. So you've got those two continents fit into it because they were once part of the same continent millions of years ago. Okay, so you've got the three main. So we're looking at the rocks now. The rocks that all these continents and are made out of. So you've got the three main rock types. So you have igneous, which means born of fire. Okay, so also sometimes just volcanic rocks. Sedimentary, as the name suggests, made of sediment. So that have been compacted, well, mostly over millions of years. Again, sedimentary rocks take a long time to form, whereas igneous can be formed very quickly, which we'll talk about in more detail in the next slide. So sediments that have been compacted, such as mud and sand. So to get things like mudstone, sandstone. And the last one, metamorphic. So that means they've been changed, like metamorphosed. Sedimentary or igneous that have been changed under metamorphosed heat and or pressure. So you can have one or both, they could be changed under. Okay, so this is a map of the UK, the geological map of the UK. So you can you can have a look at all the different rock types. I'm just going to move this a little bit over here. So you can look at all the rock types. I mean, sort of at the moment I'm near London, so we sit on a sedimentary rock that's actually called the London clay. This green section, the rocks aren't really these colours, they're just the colours to make them distinguish from each other. So London clay is like a clay brown colour, grey colour. This green part, sort of like two parts of it, is actually chalk, and the chalk is actually white, obviously. You can see the cliffs of Dover, and you see down here there's some intrusions, okay, of magma that have come up. So we're just going to talk about that in our next slide. Some intrusions. Oh, trying to change to my next slide. So yeah, igneous rock. So going into a bit detail here. So yeah, formed in two types: intrusive igneous, so formed under the surface of the earth, and extrusive, formed on the surface. So intrusive have large crystals. You can usually see the crystals, and they look quite sparkly, okay, and form below the earth's surface. So magma can come up below the earth's surface. Doesn't break the surface. It kind of just sits under there, sort of a few hundred meters underneath, and just cools down over thousands of millions of years. So that's actually what forms granite that you find in worktops. You can see the crystals in granite because they make very nice sort of ornamental floors and worktops. Also gabbro, that's found in Scotland. That's a nice rock as well, sometimes used to make ornamental things. It's extrusive. They're very different. Tiny or microscopic crystals. They form from solidified lava at the surface. So they're the ones that form very quickly at the surface, like obsidian and pumice. Also can be full of holes. We'll see in a moment. So intrusive, a little bit of more detail. Intrusive igneous. So yeah, you can see all the nice little crystals here that have been formed. When it's cooled down slowly, they're time to cool and time to form. It's a time that the crystals will form over. So yeah, down here in Devon and Cornwall, you have these intrusive sort of like magma sort of bodies that come up and they cool down underneath the surface. So it's not volcanic, it hasn't erupted. It's cooled down hundreds of thousands of meters below the surface. And we dig them up for granite, so yeah, to make our worktops with. And it's very hard and durable, it lasts a long time. But that's where granite, nice pink granite, okay? You can get white granite as well, but all used to make ornamental things. It's an extrusive, so you can see it forming. It's so quick. So it comes up, doesn't have time to form crystals. They don't have time to form, just cools down really, really quickly. Hits the air and cools down. So it forms this rock. It's called volcanic glass, obsidian, and pumice. You may have seen. Okay, it's very, very light rock. Often floats on water because it's full of gas. Because actually magma is full of gas. Okay, and it comes up. Well, it's underground. It's called magma. When it comes up to the surface, it's called lava. So the magma itself underground is full of gas, and it erupts so violently because it's so full of gas, and it forms these gas-filled rocks, which are very, very light, unusual for a rock. Okay, sedimentary rocks are very useful rocks, actually. So they come in many forms. You've got lots of different types and forms of sedimentary. So yeah, mud, sand, or even remains of plants and animals can form sedimentary rock. So sandstone is formed from sand, like on a beach, that literally like sand being compressed over millions of years, because that could be an ancient beach remains from dinosaurs were around, possibly. So the beach the dinosaurs were on. Mudstone usually formed at the bottom of an ocean, very deep ocean, that lots of fine silt and sort of silt and mud, sort of from silt is like very tiny mud particles, forms and compacts again over time to form the mudstone. Mudstone, it's not very hard. Like if I had a piece of mudstone, you could crack it on a surface, it crumbles away. So bioclastic limestone, so bio meaning life, clastic parts of. So this is, you can see, it's got shells in it and bits of living things. So this is made of the skeletons of living organisms. Again, they're compacted, possibly from a reef structure, compacted with sand and other sort of calcium deposits, so like limestone over time. They make their shells out of limestone as well. It's all kind of made of calcium carbonate, the same thing. Coal, that's formed from fossil plants, not animals, it's formed from plants. So coal was formed about 300 million years ago in swamps, so big trees that lived in swamps. A little bit different to today's ones, but a big tree that lived in swamps. died, and they fell into swamp and didn't have much oxygen to make them decay quickly. That was the important bit to form coal. Not much oxygen there, so they actually went to form the coal. That's why you can burn it, because it's actually made of carbon, made of living carbon, like a tree. Like you can burn a piece of wood, you can burn coal. Sometimes you find fossils in sedimentary rocks too. Sometimes in a piece of coal you might find a fossil leaf. Okay, and you can see the fossils found here. Okay, so yeah, they can. Sedimentary are the rocks that will contain the fossil. If you find a fossil, it will be in a sedimentary rock. So metamorphic rocks, so these have been changed. So they were a different type of rock originally and been changed. Okay, so they can be subject to heat. So that could be nearby an intrusion. So down in Cornwall, we saw before, if there was some rock that was sitting near that hot body of magma underground, it could transform it. So if some chalk was sitting nearby, it could be transformed into marble, because it actually recrystallizes itself. And if you ever see a piece of broken marble, which is unlikely because it doesn't break easily, but here you can see a picture, it's actually got a crystalline edge, it's called a sugary texture. And if you see it, you think, oh yeah, I see a sugar, because sort of sparkly, like a sugar-like texture for marble. Kyanite is a very beautiful example, and that was originally a mud rock. So mudstone, probably the most versatile of all the sedimentary rocks to make other rocks. So kyanite is formed when you have two plate boundaries that actually interact, so actually slide past each other, and that pressure in the middle, if there's mud rock there, it can pressurize the rock and it can form kyanite crystals. Yeah, they're used for jewelry, very beautiful, and they've actually got a different hardness in one direction to the other by the way that they're formed in that pressure environment. And slate is another one. So slate is here. That was also formed from mud rock, but it's been compressed. You can tell kind of by layers, can't you? It's been compressed over time by, again, a continental collision, possibly mountain forming event, formed metamorphic rocks. Okay, so I'm just going to go over a few things just to finish us off. So let's go right back to the beginning, right back. So we'll go over the learning aims. So an understanding of what geology encompasses. So it's study of the earth and everything that happens on the earth and in the earth. Okay, so you get tectonics, obviously rock forming, volcanoes, all under geology. Okay, weathering. Okay, some parts you might know as geography under geology, technically. An overview of sedimentary, metamorphic, and igneous. Okay, so sedimentary formed from sediments. Okay, that word, mud, sand, skeletal parts. Metamorphic. Okay, so metamorphosed, so changed. Metamorphosis comes from. So changed rocks, so they change under heat and or pressure, can change them. And igneous, so born of fire, so the volcanic rocks that are formed in volcanic environments, or so the extrusive igneous are actually formed from lava on the surface, which is cooled down. So you can see it forming. Okay, it's quite interesting to watch. And the intrusive igneous were formed underneath the surface of the earth in igneous intrusions. It's called the intrusions because the magma comes up and intrudes the country rock that's already there. So and the formation mechanisms, we've talked about that. So we just talked about how they all form. Okay, so thank you for joining this class. I enjoyed talking about it. Hope to see you in another video. And thank you for joining again. Goodbye.